Good morning, students. I hope everyone is comfortable and ready to learn something new. Today, we are going to learn a very important and very practical topic in Oracle. The topic is creating procedures in PL/SQL. Now, don't worry if this topic sounds new or slightly confusing. This is very common for beginners. I will explain everything slowly, step by step, and in very simple English, just like a real classroom lecture. Before we move ahead, let me tell you why this topic is important. In real database applications like banking systems, college software, payroll systems, or company projects, we do not write SQL again and again. Instead, we store logic inside the database using procedures. That is why PL/SQL procedures are heavily used in industry, and every Oracle developer must know this topic. So relax, listen carefully, and learn along with me. Before we talk about procedures, let me ask you a very simple question. Have you ever written the same SQL query again and again? For example, same insert statement, same update statement, same calculation logic? Yes? Most of you are nodding your heads, and that's perfectly normal. Now, think about this. If you write the same code in 10 different places, and later the logic changes, you will have to change it 10 times. Is that easy? No. So what if you write the code only once, give it a name, store it inside the database, and use it whenever needed? That idea leads us to procedures. Now let us understand PL/SQL first. PL/SQL stands for Procedural Language/SQL. Don't worry about the name. In very simple words, SQL is used to work with data, select, insert, update, delete. PL/SQL allows us to write programs using SQL. So what extra things does PL/SQL give us? Variables, conditions, loops, error handling, procedures, and functions. Difference between SQL and PL/SQL. Let me explain this simply. SQL works on one statement at a time, cannot use conditions or loops. PL/SQL works as a block of code, can use logic, can store code inside database. That is why Oracle uses PL/SQL to build powerful database programs. Now comes the main question. What is a procedure? In very simple words, a procedure is a named PL/SQL program stored in the database that performs a specific task. Let us break this sentence slowly. Named, it has a name. PL/SQL program, it contains SQL plus logic. Stored in database, saved inside Oracle. Specific task, like inserting data, updating data, calculations. Real-life analogy. Think about a machine button. You press one button, and many things happen inside the machine. Similarly, you call a procedure. Many SQL statements run automatically. You don't need to know the internal details every time. Now you may ask, why should we use procedures? Let me explain one by one. 1. Code reusability. Write once, use many times. No need to rewrite the same SQL again and again. 2. Better performance. Procedures are compiled once and stored, so they run faster. 3. Easy maintenance. If logic changes, update the procedure in one place only. 4. Improved security. Users can execute a procedure without directly accessing tables. These are the real reasons why companies use procedures. All right, students, now let us understand how a PL/SQL procedure actually created. So whenever we write a procedure in PL/SQL, it has some fixed parts. First of all, we write create or replace. What does this mean? It simply tells Oracle, create a new procedure, and if a procedure with the same name already exists, replace it. So we don't need to delete anything manually. Oracle handles it for us. Next comes the procedure name. This is the name you choose for your procedure. Just like we give a name to a program or a function, we give a name to a procedure so that we can call it later. After that, we may have parameters. Parameters are values that we pass to the procedure. Don't worry about this part now. We will understand parameters very clearly in the next section. Then we write the keyword begin. This is a very important word. Begin means now the actual work starts here. All the logic of your procedure will be written after begin. Inside this begin section, we write our SQL statements. For example, insert statements, update statements, delete statements, or any other logic we want. Finally, we write end. This tells Oracle this is the end of the procedure. So, in simple words, a procedure has a starting line, a name, some logic inside, and a clear ending. If this structure feels a little confusing right now, don't worry at all. Once we see a complete example, everything will become very clear. Now I will show you the general syntax. Just look at it calmly. Let me explain line by line. Create or replace procedure. This create new or update old existing procedure. Procedure name, any valid name you choose. As indicates the start of procedure body. Begin, start of executable code. End, end of procedure. Slash, tells Oracle to run and store the procedure. You don't need to remember this in one go. With practice, it will become natural. Writing a simple procedure. Example. Let us write our first procedure. Imagine I am writing this on the board. Example, display a message. Now let us understand this slowly. Greet student, name of the procedure, dbms.output.putLine, used to display output. The message is printed when procedure runs. This is the simplest possible procedure. Are you able to follow till here? Good. Let us move ahead. Now comes an important concept, parameters. Don't worry if this sounds new. Let us understand with a simple example. What are parameters? Parameters are values passed to a procedure. Just like you give ingredients to a cook, in the same you give inputs to a procedure. Types of parameter modes. 1. In parameter, used to send data into the procedure. Example, procedure show name, pname in varchar 2. Out parameter, used to send data out from the procedure. Example, procedure get total, ptotal, out number. In-out parameter, used for both input and output. Think of it like this. You give a number, procedure changes it, returns the updated value. This will become clear with practice. Now the question is, how do we run a procedure? Method 1, using execute. Use execute command and procedure name. Greet student. Method 2, using PLSQL block. Begin. Call the procedure named greet student. End. Slash. Both are correct. Make sure to write SET server output on before executing the procedure. Otherwise, output will not appear. Common errors and beginner mistakes. Let me warn you about some common mistakes. Forgetting semicolon, not using slash after procedure, wrong parameter order, forgetting set server output on. These mistakes are very common for beginners, so don't feel bad if errors come. Errors mean you are learning. Now let us quickly revise. So far, we learned what PLSQL is, what a procedure is, why procedures are important, how to create a procedure, how to execute it, where procedures are used. I strongly recommend practice writing small procedures daily. In the next part, we will write procedures with real tables and parameters. Keep practicing and don't be afraid of errors. All right, students, let us continue our lecture and focus only on understanding the scenario and the database structure shown on your screen. For now, there is no coding at all. We are only trying to understand the data. So please listen carefully. For your reference, I have already uploaded the actual database required to solve this case study. Please imagine that the schema is open in front of you right now. Now, remember this very important point. Before writing any queries or procedures, we must clearly understand the problem statement and the tables involved. In real examinations and real industry projects, many mistakes happen not because the SQL is wrong, but because the tables are not properly understood. So let us take a few minutes to understand the structure clearly. This will make everything else much easier later. Understanding the real-life scenario. Students, think of this database as part of a telecom or service-based system. Here, the company wants to store customer details, track how much each customer uses the service, and maintain customer status and reward points. So the entire system is divided into two tables, and both tables are connected to each other. First table, customers. Now, let us talk about the customers table first. This table stores basic and permanent information about every customer. Each row in this table represents one customer. Now let me explain the columns one by one slowly. Cust ID. This is the most important column. It uniquely identifies each customer. That means no two customers can have the same Cust ID. So Cust ID is the primary key of this table. Name. This stores the name of the customer. Simple and straightforward. Date of birth. This stores the customer's birth date. This can be used later for age calculation, offers, or verification. Register date. This tells us when the customer joined the service. Gender. This stores the gender of the customer. Only limited values are allowed, like M for male, F for female, and O for others. Loyalty points. This column stores the reward points earned by the customer. Initially, when a customer is new, this value is 0 by default. Later, it increases based on usage. Is VIP. This column tells us whether the customer is a VIP or not. Usually, this depends on loyalty points or usage. Status. This tells us whether the customer account is active or not. Very important point here. Only two values are allowed: active and not active. This restriction is enforced using a check constraint, so Oracle will not allow any other value. Second table, usage details. Now, students, let us move to the second table, which is usage details. This table stores usage information, not customer details. That means one customer can have many usage records. This is a transaction table. Let us see the columns. Cust ID. This column connects usage details with customers. It is a reference key or a foreign key. It tells us which customer made the call or used the service. Minutes used. This stores how many minutes were used in a particular call or session. Date of the call. This tells us on which date the usage happened. So every time a customer uses the service, a new record is added to this table. Relationship between the two tables. Now, this is very important, so please pay attention. One record in customer table can be linked to many records in usage detail table. This is a one-to-many relationship. Customer is the master table, usage detail is the detail table. Without understanding this relationship, you cannot write correct queries or procedures. Now tell me, are you able to visualize the tables? Can you see how both tables are connected using Cust ID? Good. Once the structure is clear in your mind, writing queries or procedures becomes very easy. Now, we'll start writing procedures based on this structure, step by step. All right, students, now that everyone is comfortable with the scenario and the table structure, let us slowly move forward to understand what exactly we are asked to do next. Please remember, even now, we are still thinking and understanding first. Coding will come naturally once the logic is clear. Understanding the requirement. Very important. Now, carefully read the requirement written on your screen. Write a PL/SQL procedure named Update Customer Status that updates the customer status based on total usage minutes. Let us break this requirement into simple steps. I want you to imagine this as a real telecom company rule. The company says, if a customer uses our service a lot, we will keep the account active. If the customer hardly uses the service, we may mark the account as inactive. So this procedure is nothing but automating a business decision. Step 1. Why do we need a procedure here? Students, ask yourself a simple question. Do we want to do this one time or again and again? Obviously, again and again. Every time usage changes, minutes increase, customer behavior changes. So instead of writing the same SQL logic repeatedly, we create one procedure and reuse it. That is exactly why we are creating Update Customer Status procedure. Step 2. Input to the procedure. The requirement says, accepts customer ID as an input parameter. Think logically. Can we update all customers at once? No. We want to update one specific customer at a time. So what information do we need from outside is cust ID. That is why cust ID will be an in parameter, and the procedure will work only for that customer. Step 3. What data are we checking? Next line says, checks the total minutes used by the customer from the usage details table. Let us pause here. Where is usage stored? It is in usage details table. Is usage stored in one row only? No. One customer can have many calls, many usage records. So what do we need? Sum of minutes used for that cust ID only. So in simple words, add all the minutes used by this customer. This is why we will use select sum minutes used into variable. No cursor to be used because the requirement clearly mentions we are updating only one row at a time. Step 4. Decision making. Business rule. Now comes the heart of the logic. The rule says, if total minutes is greater than 500, then status is equal to active. Otherwise, inactive. This is a simple if-else condition. Students, notice one important thing here. We are not inserting, we are updating existing customers. So update will happen on the customers table, based on calculation from usage details table. This shows how both tables work together. Step 5. Why select into without cursor? The requirement clearly mentions use select into without cursor. Why? Because we expect only one result, total minutes. Aggregation always returns a single value. Cursor is unnecessary and overkill here. So select into is simple, efficient, and exam-friendly. Step 6, exception handling. Very important. Now, students, let us understand why exceptions are mentioned. Number 1, no data found. When can this happen? Think. Suppose the customer exists but has never used the service. No records in usage details. Then, select into may not find any row, so Oracle raises no data found. So what should we do? Handle it gracefully. Maybe display a message like, no usage found for this customer. Number 2, others. This is your safety net. Any unexpected error, like constraint issues, data problems, runtime errors, etc., should not crash the program. So we use when others, then. This is professional coding practice. visualizing the complete flow. Let us visualize the procedure execution step by step. 1. User calls procedure and passes cust ID. 2. Procedure calculates total minutes from usage details. 3. Procedure checks is total greater than 500. 4. Based on result, update status in customers. 5. If something goes wrong, exception is handled. That's it. Simple and clean. Now, tell me honestly, can you see why cust ID is the input? Can you understand why sum is needed? Can you visualize if-else deciding active or inactive? Can you see why exception handling is compulsory? Good. That means your logic is clear. What we will do next is, in the next step, we will convert this logic into actual PL SQL code, write the procedure line by line, and explain each statement as we type. So relax, stay focused, and keep this logic clear in your mind. Once logic is strong, coding becomes easy.
All right, students. Now that we clearly understand the scenario, the tables, and the business rule, let us convert that logic into a real PL/SQL procedure. Please don't rush. We will understand each line slowly because this is exactly how examiners expect you to think. Procedure header. Create or replace procedure, update customer status. P, cust ID, in, customers.custid, %type. Students, let me explain this. Create or replace procedure. This creates a stored procedure in the database. If the procedure already exists, Oracle replaces it. Update customer status. This is the procedure name, exactly as given in the question. pcustid in. This is an input parameter. We are passing the customer ID from outside. Why in parameter? Because we are reading the value. We are not modifying it. %type. This ensures data type consistency with the table column. Very good practice and exam friendly. Declaration section after is keyword. V total minutes usage details dot minutes used %type. Now students, this is our local variable. V total minutes, this variable will store the total minutes used by the customer. Why do we need this variable? Because select into stores result into a variable. Sum always returns one value. Select into statement, core logic. Select sum minutes used into V total minutes from usage details where cust ID equals to P cust ID. Very important part, please focus. What are we doing here? We are adding all usage minutes for one specific customer using sum minutes used. Why select into? Requirement clearly says no cursor. Sum returns a single value. Perfect use case for select into. This line answers the question, how much total service has this customer used? Decision making using if-else. If V total minutes greater than 500, now comes the business rule. Company rule. More than 500 minutes, apply active. Otherwise, apply inactive. This is where logic meets real life. Updating customer status. Update customers set to active where cust ID equals to P cust ID. Students, note carefully. We are updating customers table based on calculation from usage details. This shows relationship between tables. And for less usage, update customers set to inactive where cust ID equals to P cust ID. So clearly, one procedure, two possible outcomes, clean and simple logic. Success message. DBMS output.put line, customer status updated successfully. This line is optional but useful. Confirms procedure execution, helpful during testing and viva. Exception handling. Very important for exams. NO data found. When NO data found, DBMS output.put line, no usage details found for the given customer. When does this happen? Customer exists, but no usage records. Select into finds nothing. Instead of crashing, program handles it gracefully. When others exception. When others, DBMS output.putLine, unexpected error occurred is equal to SQL ERRM. This is your safety net, handles any unknown error, displays Oracle error message, very professional coding style. End of procedure, by end update customer status. This ends the procedure definition / executes and stores it in the database. Students, remember the flow of the program. 1. Input custID. 2. Fetch total minutes using select into. 3. Apply if-else condition. 4. Update customer status. 5. Handle exceptions safely. If you write this step by step in practical exam, you will score full marks.